Hello, I'm gonna talk about how we can extract our common prime factors when we are dealing with greatest common factor, or like we're trying to solve divisibility problems, etc. So, when we solve divisibility problems, we often want to pull out the GCD, or the greatest common factor. So so we often use the term, so if we have A and B, right? So G, we often put G as the greatest common divisor of A and B. And we often write A equals Gx and B equals Gy, where x and y are relatively prime. Well, this is a great way to get the condition that x and y are relatively prime. So x and y becoming relatively prime is really useful because we can use many divisibility properties of x and y being relatively prime. But there's one problem with this expression, is that we don't have any information about G. So G can literally be anything if we put this in this form, and it would be actually much greater. It would be much better if we had this G being relatively prime to xy as well, right? It would be awesome if G was actually relatively prime to xy, but this is not guaranteed, of course. There are many examples, such as if we say 12 and 18, then 12 is the greatest common divisor is 6, right? It's 6 times 2 and 6 times 3. These two are relatively prime, but 2 and 6 and 3 and 6 are not relatively prime. So the solution to this problem is, we basically want to how to solve this problem is that we set A equals to P1 E1 all the way to PT ET, and B is equal to P1 F1 all the way to PT FT, where P1 all the way to PT are the common prime factors of A and B. And then we're gonna set x and y. So these are, since P1 and P1 through PT are common prime factors of A and B. So this means that x and y do not have these prime factors. So what does that mean? That means that x is relatively prime to P1 all the way to PT, and y as well. Well, this is much better because analogy would be, now we have kind of established somewhat of this form where we know more information about P1 all the way to PT, and also we can establish that since x and y are also relatively prime, we can establish that x, because they don't share any prime factors over here, and that means that x and b is relatively prime, and y and a are also relatively prime. So these additional conditions make solving questions really easier, and this kind of substitution is very important to remember. Thank you, and I hope this was helpful.